welcome to the lecture number 10 of chapter 7. So till now we have completed two congruency of triangle. The first congruency of triangle is SAS, side angle side congruency, and the second congruency is ASA congruency. Right. So today we will discuss about the third congruency, which is known as AAS congruency. Okay. So what is AAS congruency and where it is applied, we will discuss today. Okay. So let's start with the congruency AAS. Right. So let us first understand the statement of AAS congruency. What does it mean? It means if there are two triangles like this and like this, ABC and DEF. So it's supposed that if any two consecutive angles of one triangle is equal to another two consecutive angles of another triangle, and the non-included side, there is a term non-included side. What is the meaning of non-included side? See, in the previous lecture we have discussed about included side. What is included side? The side which is related to both the consecutive angles is known as included side. So if we consider this triangle ABC, then this side AB is an included side. Why? Because it is related to this angle and it is related to this angle. Similarly, in this triangle, D is the included side to the angle D and to the angle E. But here is the question, you have to take non-included side. Okay, the side which is not included to both the angles are known as non-included side. Okay, for example, here if we consider side AC, then you can see for the side AC, the vertex A is related to only one angle, but C is not related to any angle. So AC is a non-included side. If we consider BC, then only B point or B vertex is related to this angle, but the C point is not related. So BC is a non-included side. So for this triangle, AC and BC are two non-included sides. Similarly, for this triangle, DF is a non-included side and EF is also another non-included side. So according to AAS congruency, if any two consecutive angles of a triangle are equal to another two consecutive angles of another triangle, and the non-included side of this triangle, for example, we have taken BC, is equal to another non-included side of another triangle, for example EF, then these two triangles are congruent. This is AAS congruency. Did you get it? Okay, so let us write the statement. According to the AAS congruency, if any two angles and non-included side of one triangle are equal to another two angles and non-included side of another triangle, then what can we say? Then this two triangle will be congruent. Then two triangles will be congruent. So you have to keep in mind that there is a term non-included side, not included, non-included side. Understood? So mathematically we can represent it like this. For example, if we have two triangle ABC and DEF, now in triangle ABC and triangle DEF, angle A is equal to angle D, right? Similarly, angle B is equal to angle E, and this side BC is equal to this side EF. So by angle side criterion, these two triangles will become congruent. Understood? So this is the all about congruency AAS triangle. Okay. And now let us understand another theorem, that is theorem number 7.2, right? So we have to first understand this statement. What does the 7.2 theorem states? It states that angle opposite to the equal side of an isosceles triangles are equal. What does it mean? It means if there is an isosceles triangle, what does it mean by isosceles triangle? A triangle is said to be isosceles if its two sides are equal. Suppose it is an isosceles triangle, and in this triangle the two sides AB is equal to AC. Understood? Now it tells that angle opposite to the equal side, since AB and AC are the equal sides, now we have to find two angles which are opposite to this side and opposite to this side. Okay, then tell me, if AC is a side of this triangle, then its opposite angle will be this one. Understood? This one. And if we consider AB as a side, then what is the opposite angle in this direction? That means this one. Understood? So if AB and AC are two equal sides, then the opposite angle of AB is C. The opposite angle of AB is C, and the opposite angle of side AC is B. Understood? So it states that if in an isosceles triangle any two sides are equal, then the opposite angles to the equal sides are also equal. It means we have to find, or we have to prove, that the opposite angles B and C are equal. Understood? So what is the condition here? Here the condition is ABC is an isosceles triangle, and in this triangle, if any two sides AB and AC are equal, then the opposite angles B and C must be equal. Okay, we have to prove this statement. This is the concept about the statement. So let us start proving this. Okay, so first we have to write what is given. So it is given that ABC is an isosceles triangle in which AB is equal to AC. Okay, so ABC is an isosceles triangle in which AB side is equal to AC side. And what to prove? We have to prove that the opposite angles of AC, that is B, and the opposite angles of AB, that is C, are also equal. So we have to prove angle B is equal to angle C. Did you get this? Okay. Now proof. How can we prove them? Let's see. In order to prove it, we have to construct something. What do we construct? So let us first write construction. Construction. What do we construct? Here let us construct an angle bisector of A. Angle bisector of A. This is the angle A. BAC. BAC is the angle A. Now we have to draw an angle bisector of A, such that this angle bisector meet BC at a point D. Okay, so AD is the angle bisector of angle A. Okay, So you can write draw AD as an angle bisector of angle A. Clear? So what is the meaning of angle bisector? An angle bisector is a line which divides this angle into two equal halves. If it is 60 degrees, then this part is 30, this part is 30. So we can write this angle is equal to this angle. It is clear now? Okay. So now next we have to prove that the angle B is equal to angle C. How can we prove them? For this we have to compare. These two triangles, ABD triangle and ACD triangle. So let us compare triangle ABD and triangle ACD, and to prove whether these two triangles are congruent. If we can prove that these two triangles are equal or congruent, then we can say yes, their angles or their corresponding parts must be equal. So our ultimate goal is to prove that these two triangles are congruent. If these two triangles will become congruent, then you can say yes, this angle of this triangle is equal to this angle of this triangle. So let us prove that. So comparing this triangle and this triangle, we can write in the triangle ABD, in this triangle, okay, this side is equal to, in this triangle ACD, this side, because it is an isosceles triangle and it is given AB is equal to SC. So we can write that AB is equal to AC. Why? ABC is an isosceles triangle. Understood? Second thing, as you can see, AD is the angle bisector of angle A. It means this angle is equal to this angle. So in this triangle ABD, this angle is equal to, in ACD triangles, this angle. We have constructed it. So you can write BAD angle is equal to CAD angle. BAD angle is equal to CAD angle. Why? By construction. We have constructed it. Third condition. If we consider ABD as a triangle, then AD is a side of triangle ABD. Similarly, if we consider ACD triangle, then this AD is also a side of the triangle ACD. So AD is a common side to both the triangle. AD is a common side to both the triangle. So AD is equal to AD common side. Okay, we have found out three conditions here. What are the conditions? So this side and this side and included angle. Similarly, for this triangle, this side and included angle. So by SAS congruency, these two triangles can be written as they are congruent. Understood? So you can write, hence triangle ABD is congruent to the triangle ACD by SAS. This stands for side, this stands for angle, this stands for side. SAS congruency. So what we have proved? We have proved that this triangle, this small triangle, is congruent to this small triangle. Okay? But what we need to prove? We need to prove that B angle is equal to C angle. How? See? Since we have proved triangle ABD is congruent to the triangle ACD, we have proved it recently. So now remind the axiom number 7.2. According to axiom 7.2, if two triangles are congruent, then their angles must be equal. So B is an angle of this triangle, of the triangle ABD. So you can write B angle is equal to C angle is an angle of this triangle ACD. So you can write B angle is equal to C angle. These are the CPCT corresponding parts of congruent triangles. So it is by axiom 7.2. Now it is proved. Hence we can prove that B angle is equal to C angle. So what the statement? The statement states that if in a isosceles triangle any two sides are equal, then the angle opposite to the equal sides, if AB and AC are equal, then AB's opposite angle is C, AC's opposite angle is B. Then these two angles must be equal. It means this angle is equal to this angle. Okay, like this. If in the triangle ABC, suppose this side is equal to this side, then what we can write? We can write that this opposite angle is angle A and this side's opposite angle is angle C. So we can write angle A is equal to angle C. If there is another triangle like this, MNO, this side is equal to this side, then we can write that this angle, which is the opposite angle of NO side, and this angle, which is the opposite angle of MO side, then this angle and this angle are equal. This is the theorem number 7.2. So coming to the next theorem of this lecture, that is theorem number 7.3. Right. So let us understand the statement of this theorem. It states that the sides opposite to equal angles of a triangle are equal. So what does it mean? It means if there is a triangle, ABC, and if in this triangle there are two equal angles, okay, the equal angles of a triangle. Suppose we have taken two equal angles, angle B and angle C. B and C are equal. Angle B is equal to angle C. It is given. Okay. Now what we have to find? We have to find the sides opposite to the equal angles. So ultimately we have to find the sides which are opposite to the equal angles. Okay. It means if B angle and C angles are equal, then we have to find the opposite side of the angle B and the opposite side for the angle C. Okay, let us find. Then tell me, what is the opposite side of this angle? Opposite means it should lie in the diagonal direction. This angle faces towards this direction. So what is the opposite side of angle B? Angle AC. Sorry, side AC. Clear? Similarly, what is the opposite side of the angle C? Opposite means faces towards this direction. So AB is the opposite side of the angle C. So AB is the opposite side of the angle C. So according to the statement, it gives that if B angle and C angle are equal, then their opposite sides, that means AC and AB, must be equal. AC is equal to AB must be equal. This side and this side are equal. We have to prove. This is the statement of theorem 7.3. It means ultimately we have to show that ABC is an isosceles triangle. Since we have proved that this side and this side are equal, it means any two sides of a triangle are equal. So ultimately we have to prove ABC is an isosceles triangle. Okay. So let us start proving this theorem. Right. So first write what is given here. It is given that ABC is a triangle in which angle B and angle C are equal. ABC is a triangle and angle B is equal to angle C. It is given, right? So we have to prove the opposite side of angle B means AC is equal to opposite side of angle C means AB. Or you can say ABC is an isosceles triangle. Okay. So let us prove. In order to prove it, we have to construct something here. What we have to construct? We have to construct an angle bisector of A so that it meets BC at D. So AD is an angle bisector of A. Construction. AD is an angle bisector of angle A. Angle bisector means AD divides this angle into two equal halves. So this half is equal to this half. This is clear? Now proof. So how can you prove that AB is equal to AC? If we can prove that this small triangle ABD is congruent to this small triangle ACD, if we can prove that these two triangles are congruent, then we can say this side is equal to this side of another triangle. This is the axiom number 7.2 CPCT. So ultimate goal is to prove that this triangle and this triangles are congruent. Okay, by using some congruency, we have taught three congruency till now. So between triangle ABD and triangle ACD. Okay, so what are given? Since it is given that this angle is equal to this angle, it is already given. So you can write angle B is equal to angle C. Given. Second point. Since we have constructed that this angle of this triangle ABD is equal to this angle of this triangle ACD, it is already constructed. So BAD is equal to CAD. By construction. Third point. Now AD is the common side to this triangle and it is also the common side to this triangle. So AD is common side to the triangle ABD and to the triangle ACD. So AD is equal to AD. Common side. These are the three conditions that we have found. Now let us check this follows which congruency. Right. So we have found that this angle, we have found this angle and this side. So tell me, does it ASA congruency or AAS congruency? For ASA congruency, we need an included side. But this AD is not an included side because this side is related to only this angle. This side is not related to this angle. So this is not ASA. This is angle side. Angle side. Understood? So this is angle side. So by angle side congruency, okay, this two triangle ABD is congruent to the triangle ACD. Okay, so we have proved this small triangle is congruent to this small triangle. Congruent to this small triangle. Okay. Since we have to find that the two sides AC is equal to AB, how can we find it? Let us find. Since we have proved the triangle ABD is congruent to the triangle ACD. Clear? And if any two triangles are congruent, then their sides must be equal. That means this side is equal to this side. This side is equal to this side. AD is equal to AD because these are the CPCT through axiom 7.2. Since two triangles are congruent, then we can say that this side AB of the triangle ABD is equal to this side AC of the triangle ACD. Okay, by axiom 7.2. Hence, we have proved what we need. Okay, this is the proof. So finally we have proved if in a triangle any two angles are equal, for this M and O, if this angle and this angle are equal, then their opposite sides, for example, the opposite side of N is MO and the opposite side of M is NO, then this side is equal to this side. Okay. So this is the theorem number 7.3 and you can see that this theorem or the statement of this theorem is just opposite to the statement of theorem 7.2. In 7.2 we have discussed that if any two sides are equal, then their opposite angles are equal. But here we have discussed if any two angles are equal, then the opposite sides are equal. So both the theorems are contradictory to each other. They are converse of each other. That is why theorem 7.3 is also known as converse theorem 7.2. Clear?